Today we're going to address the ideas of Don Hoffman, a cognitive psychologist and popular author. He may be known to the larger audience from his TED Talk titled Do We See Reality as It Is, which has been viewed more than 2 million times. I'm also going to draw material from a number of podcasts which feature Don Hoffman as a guest, as well as his published articles. The general claim made by Hoffman is that our perceptions are an interface that has nothing to do with objective reality. And he uses an analogy of a computer desktop where file icons are mere symbols of the complex processes behind the scenes. And these symbols allow us to control reality, but not see it for what it really is. For example, file icons have shape and color, but actual files do not. And yet, dragging a file into a trash bin actually deletes a real file. So he usually puts it this way: you should take the file icon seriously, but not literally. He backs this up by reasoning that evolutionary pressure disfavors accuracy and favors fitness, which he claims rarely go hand in hand, and that we evolved to survive, not perceive reality as it is, and even more than that, that in order to survive, we needed to perceive reality not the way it is. So let's see how he makes his case. He usually starts off by making an observation that we've been wrong before. We used to think that the Earth is flat because it looks that way. Pythagoras discovered that we were wrong. Then we thought that the Earth is the unmoving center of the universe, again because it looks that way. Copernicus and Galileo discovered again that we were wrong. Now, that seems like an uncontroversial claim, but I think it's important to note to what extent our perceptions are to blame here. So he says that we used to think the Earth is flat because it looks that way. But we can't actually see the Earth as a whole. We can only see a minuscule part of its surface. And at this scale, the curvature is so small that perceiving the surface of the Earth as flat is not an error of perception. How else should a creature of our size perceive a planet? Rather, it was an error of inference. We were certainly wrong in thinking that because our local surroundings appear to be flat, the whole thing is flat. But that has very little to do with our perceptions. Of course, one can say that had our retina had better resolution, we could have spotted the curvature even from the elevation of our natural height, but that speaks to the accuracy of our perceptions and does not demonstrate that they are completely wrong. Low accuracy and being completely wrong are different things. In fact, the idea that at a certain scale a round object might look flat, I think is an interesting insight into reality. In 2018, a photographer put out a picture that went viral very quickly of a surface of a basketball. It was taken at a large zoom level, and it looked completely flat. The understanding that to a tiny creature that lives on that ball, it would appear so horizontal, I think that's not as trivial as it seems. Anyway, this is in response to Hoffman's assertion that our previous imperfect beliefs about the world were completely and utterly false. And I'm saying that in each of those instances, there was at least some truth to them, and that not all of it was error of perception. But let's look at the way he argues about our perceptions being a mere interface. He brings up an example of heat. When we put our hand into a bathtub of water, we feel that it's either cold, lukewarm, or very hot. But a physicist will tell you, of course, that there are actually trillions upon trillions of molecules interacting with one another, and that creates heat, but we're perceiving just basically one number. And Hoffman calls this data compression, and that our perception of temperature is an interface, the purpose of which is to simplify reality in order to give us an adaptive advantage. He then says, and this is a very important quote, that the symbols of our interface don't even resemble objective reality. But what is the definition of objective reality then? And what would be the correct objective perception of, say, heat? Is he saying that we need to perceive every single molecule in the bathtub and only then we will truly see the world for what it really is? But if that were possible, we would not actually experience heat, right? Because heat does not exist at the level of particles. Heat is an immersion property. Heat is what happens when trillions of molecules interact. So the fact that we don't perceive individual molecules does not mean that our perceptions don't map to reality or that they don't resemble objective reality. In one of his articles, he goes even further and suggests that we have to, and I quote, persuade most physicists to reject local realism. Our untutored categories of space-time and objects would lead us to expect that two electrons a billion light-years apart are separate entities. In fact, because of entanglement, they are a single entity with a unity that transcends space and time. Now, this is a very strange thing to say, because first, the principle of local realism, which theoretically could have been violated by quantum entanglement, all that makes sense on quantum level only. These quantum effects are simply non-applicable to the macro world. For instance, non-locality does not mean that information can travel faster than light. It still can't. And even if all physicists embrace non-locality, it won't really change special relativity, it won't change our perception of space and time and our understanding of space and time. So, is Hoffman again saying that macro world doesn't count and all that matters is only the world of particles? But second, the implications of quantum entanglement, locality, non-locality, action at a distance, all of that are hotly debated topics in modern physics. And there is currently just no consensus on that among experts. Hoffman is not an expert, yet in his paper, he suggests that physicists reject local realism. Why? I'm always concerned when a non-expert gives advice to experts, especially in science. And the fact that he equates quantum entanglement with non-locality, that kind of hints that he may have only a very cursory understanding of the subject. Entanglement is necessary, but it's not sufficient for a state to be non-local. But then it becomes even more bizarre. In his TED Talk, he says that even knowing that matter is composed of particles is still not objective reality. And he again uses his desktop analogy. He says, imagine you use a magnifying glass to zoom in into the file icon and you'll see pixels. And then you'll think, hey, this is the reality of the computer, but it's not. And so he claims that even understanding microparticles, all of that is still the user interface. So the more you listen to his arguments, the more you realize that he misses this key definition, the definition of objective reality. Because his examples sound convincing at first, but once you start asking questions, they begin to fall apart. On the After On podcast, the host Rob Reed actually asks Hoffman this question, what is objective reality? And Hoffman replies, the right answer is I don't know. And that's a problem. If you're putting forth a hypothesis that what we perceive is not objective reality, but then you don't have a definition of objective reality, what kind of hypothesis is that? In fact, is it even a scientific hypothesis at all? One has to be able to make predictions, and nothing about what Hoffman says seems to offer a possibility of making predictions. Even if I agree with him, there doesn't seem to be anything that really changes about my worldview. It's similar to solipsism. Yes, maybe I'm a brain in a vat, but there's no way for me to know that, and I'm stuck with the reality I'm in. So, at the end of the day, Hoffman's general proposition seems to be an unfalsifiable one. But he does offer some proof or some evidence for this, and eventually his main argument are his evolutionary simulations. He claims that, and I quote, in my lab we have run hundreds of thousands of evolutionary game simulations with lots of different randomly chosen worlds, and organisms that compete for resources in those worlds. We let some creatures see all of the truth, we put others that saw nothing of the truth and were just tuned to the fitness functions, and we let them compete. And what we found uniformly was that organisms that saw the truth never outcompeted organisms of equal complexity that were just tuned to the fitness functions. That's his key claim. And it is an unusual one, but extraordinary claims require extraordinary evidence. So let's take a look at Hoffman's evidence, because I bet many of us watching the TED Talk, listening to Hoffman on podcasts, wanted more information on those experiments. For instance, what does it mean to see all the truth and to see none of the truth? How can you compete if you see none of the truth? And how extensible are those models? What if this relationship between truth and fitness works in a very simple model, but when more parameters are involved, having an accurate model of reality becomes critical? And by the way, Hoffman likes to repeat that they have run hundreds of thousands of simulations, and I guess that's supposed to sound more impressive, but they're running MATLAB programs. When I was doing my thesis, I also ran hundreds of thousands of simulations. There's nothing very impressive about it. I mean, it's a small thing, but I just feel that this adds undue weight to his claims in the eyes of the lay audience. Anyway, in an article titled The Interface Theory of Perception, Hoffman gives a description of one of the simulations. Two animals compete over 3 territories. Each territory has a food value and a water value, each value ranging from 0 to 100. The animals can adopt one of 2 perceptual strategies. The truth strategy perceives the exact values of food and water for each territory, and this is estimated to be around 40 bits of information. The simple strategy only perceives if the food and water values are greater or lower than 50, a binary perception of sorts, and thus the total amount of information that the simple strategy perceives is 3 bits. The model then assigns a resource cost to obtaining perceptual information based on the amount of used up bits, and this cost is subtracted from the sum of food and water supplies. There is also a time cost to obtaining information, which means that the animal with a simple strategy always acquires information faster and moves first in the simulation. So this seems to be the setup. And if you think about it, I think that it's immediately not very impressive. It doesn't seem to be very insightful. First of all, seeing part of the information is not the same as seeing no truth at all. Sure, in this particular case, being less accurate but more fast matters. But it's not like the simplified version doesn't say anything about reality. It builds a simpler model, sure, whereas Hoffman's claim is that symbols of our interface, remember, don't even resemble objective reality. I don't see how this setup helps prove that. But there is another problem. If we're talking evolution, and an animal is already capable of perceiving something, this should not incur so much cost. Sure, obtaining a feature carries a cost on an evolutionary timescale, but I'm not sure that the cost should be so directly tied to time and resources. And the way the experiment is set up, one doesn't need any calculations and formulas really to see that if you have to pay for every single bit of information with your time and resources, an animal that has to pay only for 3 bits will definitely always defeat an animal that has to pay for 40. This is quite trivial. He probably understands that, and in his paper says that the resource game just described might seem too simple to be useful, so one can, he says, expand on the simple game in several ways. And then he proceeds to list these several possibilities. But interestingly enough, he never went on to actually model any of those more sophisticated simulations. So he seems to be content with the one that he did do, and then concludes by saying that his bet is that even if you devise other simulations, they will not demonstrate evolutionary pressure for true perceptions. And that just seems to be an opinion, not science. And I think one has to really be sure before going on TED to tell everyone that everything they believe is wrong. I did decide to dig a little deeper, and in a yet unpublished draft article, but which is published on his website, titled Fitness Beats Truth in the Evolution of Perception, Hoffman and co-authors give a description of another simulation. So this time the setup is slightly more complicated, but the idea is still the same: organisms competing for territories. So he again outlines 2 strategies, the truth one and the fitness one. The truth strategy estimates the world state which is more likely to be true using the Bayesian model, and then estimates the fitness payoff of territories, picking the best one. But it ignores any fitness information about world states that it doesn't deem to be true. Now, the fitness-only strategy ignores the estimation of a true state altogether and directly computes the expected fitness payoff. And models again show that the fitness-only strategy wins, and just like last time, I'm not really convinced. This time, my objections I think are more fundamental. First of all, I have a suspicion that he's constructing a strawman argument here. He suggests, by the setup of his experiment, that the mainstream claim is that a successful organism focuses on truth first. And I'm not sure I ever heard such a claim. The claim is rather that the focus is on survival, and that focus eventually tends to produce perceptions that reflect the real world. So while his models can be correct as far as they go, in order to challenge the mainstream, Hoffman needs to show that as generation of fitness-only organisms evolve and evolve and evolve, they never evolve accurate perceptions of world states. But his simulations never really go there. Second, I suspect that he's equivocating on the term fitness. In this same article, Hoffman says that in evolutionary theory, fitness is a measure of the probability of transferring genes into the next generation. But then, if this is what fitness is, how can an organism calculate it? An organism can calculate resources, right? But not how likely its actions are to transfer genes into the next generation. Evolution by natural selection works on a population level. There is no direct way to calculate fitness beforehand. And in his fitness-only strategy, an animal ignores the true state of the world and directly computes fitness payoff. But how can an organism actually do that? Perhaps I'm completely out of my league here, and Hoffman has answers to all of these objections, but at least on the surface, I just don't see how both of these simulations demonstrate his conclusions. But there are things that I can say. What matters in science is the eventual consensus of experts, so no matter what I say here, experts in relevant fields should comment on Hoffman's experiments. And I, for one, was not able to find any discussions, reproduction of his models, or any other indications that his work is even being actively discussed by the experts of the relevant fields. Maybe it is being discussed, I just couldn't find it, and my search results mostly return Hoffman's interviews on podcasts, articles in popular magazines, that kind of stuff. But the fact that he's so actively promoting his views to the general public, while a lot of his work is very, very preliminary, that concerns me. Another thing that matters in science is, of course, empirical evidence. Even if Hoffman's models commit no errors, they are correct, do they actually correspond to reality? After all, math is just an instrument. One can model anything via math models, even things that don't exist. So surely the only way to really prove that Hoffman is correct is to move from modeling to empirical demonstrations. And so far, his examples of our perceptions failing in the empirical world are not that great. For instance, he likes to tell a story about Australian jewel beetle, and it's kind of a fun and sad story at the same time. The species was almost drawn to extinction actually in the 20th century due to the males trying to copulate with discarded brown beer bottles. And they were apparently attracted by the refraction of light produced by the glass bumps of the bottles, and that just resembled the female, a very large female beetle. And so the beer company had to change the design of the bottles to prevent that from happening. Hoffman uses this example to say that this shows that the beetle does not perceive reality as it is, but instead operates through an interface which, remember, he says has no resemblance to reality. But his own example seems to be self-defeating. Doesn't the male beetle mistake the bottle for a female precisely because it resembles the female? Doesn't it mean that the beetle perceives something true about how the female actually looks? Again, the evolutionary claim is not that natural selection favors getting all the information down to the millionth digit. It favors getting in line with reality up to a certain point, but almost never to a full degree. What matters is simply what is enough for survival. And I don't see how the beetle example shows that just because it uses a quick and dirty heuristic to find a female, it shows that the beetle knows nothing about objective reality, like nothing at all. And by the way, in every example he brings up, it very quickly becomes clear again that not having a definition of objective reality makes it impossible to have meaningful conversations about any of this. Because Hoffman is effectively saying, actually as a response to, hey, doesn't the beetle actually perceive something of reality? He says that not only does the beetle perceive reality in a completely wrong way, but that we do too. So both the beetle and the bottle are just icons that have no resemblance to real beetles and bottles. But what are these real beetles and bottles? And Hoffman doesn't even have a definition of what he means by objective reality. He says he considers the nature of objective reality to be an open scientific problem, but that makes his argument premature then. First show us there is an objective reality that differs from what we think we see, then we'll talk about it. And now we come to a hypothesis of my own, an answer to the question, why does Hoffman need this complicated construction? Is there an end goal to his narrative? Well, let's see. In his TED Talk he says, quote, "Perhaps reality is some vast interacting network of conscious agents, simple and complex, that cause each other's conscious experiences. Actually, this isn't as crazy an idea as it seems, and I'm currently exploring it." End quote. In his article, The Interface Theory of Perception, which we already talked about, Hoffman writes, quote, "When a file icon is dragged to the trash and disappears from the screen, is the file itself destroyed, or is it still intact and just inaccessible to the user interface? Knowledge of the interface itself might not license a definitive answer. If not, then to answer the question, one must add to the interface a theory of the objective world it hides." End quote. And this, ladies and gentlemen, I think is where Hoffman is really going with all of this. He basically puts forward a theory that the world is based on consciousness. And while he mentions this only in passing, that consciousness is more than what the brain does and life after death is maybe real. In a 2014 article, Objects of Consciousness, in the abstract, Hoffman writes this, and this is a very interesting quote. "We show that one particular object, the quantum-free particle, has a wave function that is identical in form to the harmonic functions that characterize the asymptotic dynamics of conscious agents. Particles are vibrations not of strings but of interacting conscious agents. This allows us to reinterpret physical properties such as position, momentum, and energy as properties of interacting conscious agents, rather than as pre-existing physical truths." This is where it begins to sound more like pseudoscientific word salad. Particles are vibrations not of strings but of interacting conscious agents. I think I heard something like that. That style of speech just resembles someone. And it turns out I was just 2 clicks away from Hoffman's Wikipedia article, which says, amongst other things, that Hoffman is an advisor at the Chopra Center. And Chopra Center is a wellness and meditation center founded by Deepak Chopra. If you don't know him, look him up. That promotes Ayurvedic remedies and teaches the ideas of Osho. I'm kind of glad I discovered this only after I developed my criticism, since I feel that this could have biased my perceptions.